This video will cover the empirical rule. If a distribution is bell-shaped and symmetrical, the distribution will have the following qualities. Approximately 68% of the values will fall within plus or minus 1 standard deviation. Approximately 95% of the data values will fall within plus or minus 2 standard deviations. Approximately 99.7% of the values will fall within plus or minus 3 standard deviations. This is known as the empirical rule. Knowing this information will help us determine percentages for application problems. The following graphic shows the empirical rule all in one graph with the percentages subdivided. For example, the empirical rule states that 68% of the data is plus or minus 1 standard deviation. So the mean is here, and to the right of the mean is plus 1 standard deviation, and to the left of the mean is minus 1 standard deviation. Since this section contains 68% of the data, if we divide that in half, we get 34% in each section as stated here. The other portions of the normal distribution have the percentages filled in for those sections. To find these values, it involves a little bit of subtraction and then division, but for now we'll just use the values that are on the graph. Let's do a couple of examples. We'll start with this first example, that is the scores on a test are normally distributed with a mean of 100 and a standard deviation of 20. Part A says to find the score that is 1 standard deviation above the mean. So I'll start by drawing the normal distribution and putting a line in the middle here for the mean, and the value for the mean is 100. So now I'm going to label the first standard deviation above the mean. So 100 plus 20, which equals 120. This is 1 standard deviation above the mean because I did the mean plus 1 standard deviation. For part B, I'll draw another normal distribution and label the mean here, 100. Next, I will label the first standard deviation below the mean. So 100 is the mean, minus 20, the standard deviation. So that's 80, which is 1 standard deviation below the mean. Since the problem asks for 2 standard deviations below the mean, I will subtract another standard deviation of 20 from 80 to get 60. This is the second standard deviation below the mean. Now on to part C. 1.5 standard deviations above the mean. So again, I'll draw the normal distribution. Then I'll add the mean in the middle. And we already know what the first standard deviation is above the mean because we did it in part A. So I will put that down as 120. But this is only 1 standard deviation above the mean. The problem asks for 1.5 standard deviations above the mean. Well, so since 1 standard deviation is 20, that means a half of a standard deviation is 10. So I will add the 10 to the 120, and that gets me to 130. That is the score for 1.5 standard deviations above the mean. The next question says to find the percentage of data values between 80 and 20. So what I'm going to do now is combine a few of the things from parts A, B, and C. We have the mean is 100, and then when we add 1 standard deviation, we're adding 20 each time. So 100 plus 20 is 120. This will be 140 because I'm adding another 20. Below the mean, I'm subtracting 20, so 100 minus 20 is 80. Then minus another 20 is 16. The next thing I want to do is take all these percentages here and put them on that little graph I just made. So we have 34, 34, 13.5, 13.5. And that's all I need for this problem. Problem D is saying, what is the percentage between 80 and 120? So here's where 80 starts. We go up to 120. And that is going to be the 34 plus 34. This is 68%. Now, the next question says, find the percentage of data values that are greater than 120. Now, to do that, I'm just going to use the same graph, but I need to add on a couple more standard deviations and a few more of the percentages. When I add on another standard deviation of 20, this is going to be 160. And then I'm going to go ahead and put in the percentages. This will be 2.35, and this is 0.15. Question E says we want to find the percentage of data values greater than 120. So I'm going to start here. It'll be everything in the tails. So this will be 13.5 plus 2.35 plus 0.15. This is going to be 16% of the data values are greater than 120.